Hello, everyone. It's nice to see so many people in here bright and early on Monday, and especially return visitors and new people are welcome also. Hello, everyone on the stream. So we're going to kind of dive right in today. So I do have some bad news. We looked at all the fun projects last week, and now we have to talk about technology for a while. So it's maybe the first part of this may be a little dry because we're going to kind of actually go deep in and talk about different options for microcontrollers, what you can do with them, what they're for, but really talk about the devices. If you still need a sense of what are these for? How do you use them creatively? What are the projects? We will look at some of that today, but I would encourage you to go check out the stream from last week that was called Sensing the World, where I just kind of went over a bunch of projects of how you can use sensors to do fun creative things. So it'll be fine. We'll go through it. I'll talk. Those of you that are here, you can play. I'm going to post links also so you can kind of follow along. So first piece of housekeeping, if you want to go to workshops.j38.net, you should see the notes, these notes that I'm using basically, and that might just make your life a little easier. It's this going deeper with microcontrollers link, because as I call out certain things, there will be links here that I'm following, and if you want to follow along, you can follow along, and then also these notes will be up in the future, so if you need to go back and reference something. So that is the first piece of housekeeping. The other piece is the thing that you've probably heard me say 10 million times, but I'm Scott. I've met a fair number of you, and it's nice to see you back. And just to give a bit of background for those that I haven't met or anybody watching on stream who has not already heard me talk a million times for SETI, is I am an artist. I kind of consider myself a multidisciplinary artist, and really the key for me is putting lots of different threads together in my creative practice. And so that is sort of design and visual arts, time-based media, even music, sort of what you might think of more traditional creative realms, along with craft and physical fabrication, craft, woodworking, materials and tools, that kind of thing, like physical work to create real objects that exist in the world, and technical skills, which is writing software, building hardware, all kinds of things. But I like to do all of it personally, and I like to kind of hook all those threads together and see what I can create by putting those pieces together. So I'm going to talk kind of at length today and go not on a super deep dive, but kind of on a dive on what are microcontrollers, what can they do, what are the capabilities of them? We're going to dive in specifically to a device called the Circuit Playground Express because we have a lot of them. And we will, during the second half of today's workshop, we will go play with all of those. But for those of you, and I think everybody in this room is already kind of starting to play, there's some links here that if you just want to dive in and start playing around, you're very welcome to. And one of the cool things I think about the Circuit Playground Express is that it has tons of sensors built in, and it also has a fair number of what I would call indicators, maybe actuators. We could go back to last week's talk and debate on whether sound is an actuator or an indicator, just built right in. And something that is super cool and super handy, in my opinion, is that you can fully simulate it. So even if you're at home and you don't have this device yet, maybe you're thinking about ordering it, you can still start to follow along and play with some of these tutorials because it actually has a simulator for the device. Hello. Miguel, would you mind being replaced? Great.
I'm sorry.
No, that's okay. You're fine. Miguel will help you get set up. So you can see here in the software, one of the things that's really nice about this is that you can actually do almost everything that this little board can do just up here in the corner. Like I can click buttons, I can slide a little slider, and we'll go more deeply into that. But it's something I really like about this particular device, even though honestly, I will say I'm quite new to this microcontroller. Or development board or whatever. We'll have to decide what we want to call this. But it is kind of handy because you can start to experiment, play with some of the tutorials without even worrying about the hardware. So I just wanted to give that as an option to everyone in this room. But you also have the option to go at a slower pace with me and we'll kind of unpack it, or you can just dive right in and play or do a mixture of both. For me, the way that I learn to do things is very much just hands-on, start to go. So feel free to do that. Just make sure your volume is not turned all the way up when you do that. So the talk I gave last week was called Sensing the World, and we went through lots of my projects, and maybe it bears just a quick review of some of those projects and kind of my path through it. And so definitely I gave that full talk. You can view it at length, but just for the people new or who are just diving in now, I've been making these kinds of projects for somewhere in the order of 15 years. This is one of my very first physical computing Arduino projects. It was a very silly project where I just made some piano gloves so I could play piano on any surface. And if we kind of go down here and ignore the fact that I'm wearing a scarf indoors and ignore that I didn't really know what I was doing and had all these problems, let's see, I can probably play this and we'll just hear it over the loudspeaker.
I'm
And that way
Garner,
down.
and I wanted to
So I'm sure some of you, if you've seen me do stuff, have probably seen me talk about this in other places.
much
But
more exotic components that would like you.
let's see if we skip to the end, they'll probably play. So very simple project. It was really my way of like diving in and learning. But the reason I want to touch on it here is if we go down and we look at all my fancy pictures of all the things that I was learning, figuring out, and learning what a pull-up resistor was and all those kinds of things, as we go along here, you'll see this, this is an Arduino NG. I'm not even sure these are made anymore. This is an early version of an Arduino. But the important part about this, the role this fills in the project is something we didn't talk about last time, right? We talked about the buttons, or okay, the buttons, you can press a button and then something's gonna happen. We're not even talking about that yet. Now it's time to talk about what that is. And so we talked about things like sensors, like buttons, like light sensors, or various kinds of radio for picking up different kinds of electromagnetic radiation, of pressure sensors, tilt sensors, all these different kinds of sensors. But we didn't really talk like, what do you do with that information? Like once I press a button on the end of my finger, what actually makes that play a sound? Like how do we get to that piece of the equation? And so what is missing is the piece that handles the incoming and the outgoing data. And the really easy metaphor for that is, I, as a human, when I grew up, we would always talk about humans having 5 senses. I think humans have way more than 5 senses. And I think you can find literature that would say humans have more than 20 senses if you count things like hunger and various other things that humans are capable of sensing. But if we go back to being kids in kindergarten, we talk about, I have sight, I have hearing, I have the ability to smell and taste and touch. That's all well and good, and I have the tools to do that, but something has to happen to that information. And in the human body, we have impulses that travel through our nervous system to our brain, and then it's our brain's job to take that information and do something with it, right? And reason about it. And maybe react to it, cause behaviors, cause things to happen based on that. So for the purposes of today, when we're talking about a microcontroller, we're really just talking about the brain. It's the thing that is going to do the work. And it's what a microcontroller means can be a little confusing because it's one of those things that can refer to very specifically the single tiny chip that's on this board, or it could refer to this whole board. So we'll try to navigate through some of the terminology, but just if you're just starting out, you can just think of it, it's kind of the brain. And as the brain, it really is just a simple computer. And all of these have these tiny little simple computers. It's very different, and we'll talk about why, from a desktop computer, a laptop computer, or a phone that are designed to do all kinds of things and have tons of programs running. Typically, these are running a program, right? They have one special purpose that you give to them, and they're going to do that one thing. And that makes them very flexible, very powerful, often very inexpensive because of that. So, if you buy a processor, the processor that's in this iMac that's in front of me might be a $700 processor, whereas the processor that is on this Arduino, the little chip that's on this Arduino, only costs $3. And so it is just orders of magnitude less expensive, which really matters if you're trying to make a whole bunch of something, right? So I keep using the term microcontroller, and some of you maybe have a vision in your head of what that means. I'm going to talk about 3 of them. And again, there's some fuzzy terminology here, and you're going to hear me probably mix the terminology back and forth just because I think it's fairly common to do so. But we're really talking about these boards, these little breakout boards. So I think everybody in this room has one of these little Circuit Playground Expresses. So just to be really clear, I will often refer to this whole thing as a microcontroller. Technically, the microcontroller is really this little kind of black postage stamp on here. That little processor, that little chip is actually, quote unquote, if you look at the data sheet, that's the microcontroller. For the purposes of today and most of what you're doing, you're very rarely will you probably have to think very hard about that chip, because sort of the whole point of this board is to make your life easier in dealing with that chip. This chip is a very tiny little surface mount version. And we'll look at all these things more closely later, so don't worry if you're not kind of seeing them up close and personal. But on the Arduino, it's a much bigger thing. It's a much bigger object. This particular Arduino Uno has a through-hole version, and it's just a big object that you can hold in your hand. And this is the brains of this. And this one only costs about $3, but it's kind of slow. It's a bit old. It's not super powerful, but it's a really flexible little device. So you just have to forgive me because I always call this whole thing a microcontroller, and that's very common. You could also call it a development board, maybe slightly more appropriate, but just to set the expectation of like, what is the object we're talking about? It's these kinds of little things where someone did some work for you to solve some problems with software, solve some problems with electrical engineering, so you can just get started making fun stuff and not have to worry as much about the intricacies of these tiny little chips that are on here, okay? So I've already showed you 2, and I'll just pull out a teensy so I can have all 3. I'm going to talk about 3 boards today, and that's, sorry, I grabbed the wrong package. I grabbed the proper package for the teensy audio programs. Okay, here we go. Just so we have some points of reference for what these look like. So I'm going to talk about 3 specific sort of lines of these little development boards, these little prototyping boards, microcontrollers. The 3 that we're really going to get into, and one in particular we will get deeply into, we're going to talk about the Arduino, which is a very long-standing platform. This one's been around for almost 20 years now, and it's pretty amazing for a lot of reasons. It's where I got my start. It's where a lot of people got their start. I don't use it quite as much as I used to, but I still use it a lot. Like an Arduino is a pretty amazing thing. And so we'll talk about why that is and why you may be interested in an Arduino more than another.
The computer just crashed.
It did just crash, maybe
No,
Miguel?
the Adafruit thing just crashed.
Oh, okay.
It's just frozen.
Yeah, I might have to kill the browser and come back.
It's not-
Also is the teensy. So here's an even little smaller breakout board. You can see it's quite teensy, and everybody in the room, we can get a closer look later, or you can follow the link on the site. Extraordinarily powerful. Like this tiny little board is actually probably several orders of magnitude faster and more powerful than this one. This is a locally designed board, Paul Stoffergen at PJRC. Hope I get the company name right. Okay, Miguel's got it. Designed this. He's an incredible engineer. We'll get this. This is my favorite microcontroller for a lot of reasons, but it's pretty advanced. And then we will talk about this Adafruit, which I always get backwards. Miguel will tell me.
It's kind of both.
Kind of both. Okay, we'll go both ways. Interchangeable. Is the Circuit Playground Express. And the real advantage of this is it has so much stuff already built into it. So going back, if you watch that sensors talk that I gave last week, I talked like about 10 different kinds of sensors, 12 different kinds of sensors, and probably 3/4 of them are actually on this board. And you can even see, going back to the piano gloves, the even almost literally the same part number, the little tiny buttons I have here on the fingertips are the same kinds of buttons that are right here. They're the same buttons. And when I'm going through a few other projects that you can see back in the last stream, for example, the tilt sensor that I have in still life. So this is a project that causes a picture frame with don't want to totally rehash everything, but you can grab this picture frame and you can tilt it, and the artwork on the frame will tilt and move around because I had an accelerometer. I think it was actually an accelerometer and a gyroscope, but basically there was a motion sensor on the back of the frame. There's also a motion sensor on this tiny little thing. And so this is a great place to start in that it's very self-contained. It has lots of cool stuff built into it. There are some downsides to that, but we'll talk through kind of what are the pluses and minuses a little bit. So that's kind of our trio. So again, I would say like the Arduino is kind of the old school hero. It has been around for a couple decades. It has so many examples, so many resources. It really is an incredible device. And it's kind of at the top of the family tree of devices like this. We have the Teensy, which is so tiny, so powerful, local product, great for driving tons of LEDs. Like if you have 1,000 LEDs, this is probably the way to do it. And we have this little Circuit Playground Express. And so we're going to talk about these. We're going to mainly work with the Circuit Playground Express. That's kind of what we have a lot of at SETI to get started playing with. Let's dive into some high-level notions of these. And in fact, I do want to just go through these while we're at it and just show you, because I think it's worth looking at these sites, because Arduino is a pretty incredible platform, so you might want to just scroll through here, see all the different things, all the different flavors of it. Teensy also actually has kind of a line of different sizes, different capabilities. Again, this is the local company. Paul Stoffergen comes and hangs out at certain SETI events, and he's a really amazing resource. And again, there's the Circuit Playground Express, just to throw these up on screen to just start getting a mental model for what these are, especially for anybody watching at home. So we're going to talk about hardware basics. It's obviously a deep subject, right? When you look at this, there's so many tiny little things on here, tiny little components. Some of them are sort of hard to identify. Some of them I would have to get a microscope to even tell you what they are. But that's okay, because part of the point is that a lot of the work is done for you. And so just to describe as an example, I mentioned there's often a chip that's acting as the brain of this. And so when we looked at that Arduino and we looked at, for example, Arduino Uno. So if we go in here and find an Arduino Uno, let's see if we can find my favorite board. Yeah, Arduino Unos are great. I mean, they're classic. They've been around for a very long time. Versions of it have been around for a long time. So this is the whole breakout board. But as I mentioned, really, this is the chip. This is the brain, right? This is the microcontroller. And we can, and this is true for most electronic components, find what is called a data sheet for that, and it will just kind of tell you everything about that chip. So I think if we went here, you might just want to know that this is a thing that exists in the world, but it's a pretty deep topic. And so this is, if you're, for example, designing hardware, you work at an electronics company, you're an electrical engineer, you would be looking at this. You would get these chips from some distributor. You might be building a toaster oven at home that has a computerized timer in it, or a microwave oven, or a router, or something like that. Like these kinds of little brains are in all kinds of things in your home, or similar kinds of objects to this. And you can just see how long this document is, and how complicated this little chip is, this little device, this little thing right here. All this documentation is telling all the electrical characteristics, the programming capabilities, the different kinds of inputs and outputs. It's tenable. Like you could, obviously anybody in this room could really think about it, go through it and work through and understand this, but it would definitely take some time. So what these boards offer you is somebody has kind of done a lot of that work for you, so you don't have to dive deep and get super deep into these, the complexity of the electrical properties of these devices. And they have just built this sort of these handy little boards that do so much work for you. So I think that's something to keep in mind here, is that these are very often the chips on these are widely used in other consumer electronics and other contexts, but Teensy or Arduino or Adafruit has kind of done the work to like build some scaffolding to let you use it without having to deal with all that complexity. And so it includes so many different kinds of conveniences for you. And even just looking at these kinds of boards, and obviously for those of you in this room who plugged them in, you recognize like, oh, I can just plug a USB cable into this and plug it into a computer. That's not something that is implicit in the chip, right? That is work that someone had to do to make that easy for you. Same thing with adding power to this. Same thing, for example, on the Circuit Playground Express, for example, very talented designers at Adafruit designed this circuitry, built in all these sensors, everything, so you can kind of get a start to it. So I think it's a pretty amazing thing. And I think we'll talk about this more, but I really think of Arduino is kind of like the root, that corner of hobbyist electronics, of that family tree, is really trying to make this kind of stuff accessible to normal humans, right? Not like intense electrical engineers where only a small fraction of the population has access. We're able to do these cool things with it. So as I mentioned, lots of very simple conveniences, let you plug it into a computer, built-in buttons, built-in power regulation, all these things that are done for you so you don't have to worry about it. But what really makes these powerful, like really what matters about these, in my opinion, is the quote-unquote pins. And just to show you on the Arduino Uno, so we were just looking at that cute little Arduino Uno, these are the pins. And pin is a kind of loose term. You will see just even across the three devices I have in my hand, pin means a slightly different thing. So on an Arduino Uno, for example, when we talk about pins, you see these they look like little plugs. We would call these female header pins. Those are a place to plug in wires or connectors or other electronics. On the Circuit Playground Express is a little bit different. They actually have these big holes, and they're not designed for wires to plug in. They're designed for big alligator clips to clip on, and we'll look at that later. The Teensy kind of gives you an option. This Teensy that I have actually doesn't have any pins at all. And so I could solder female headers or male headers to be able to plug into it. And so we'll talk a little bit more, and we'll look about it certainly when we start getting more hands-on, like really what we mean by pins. But so there's the physical version of what a pin is, right? And in some cases, it's literally just a little piece of metal that sticks up like a little pin, and that's where the name comes from. But there's also the conceptual version of what a pin means in these contexts. And going back to this image, this may look kind of daunting and overwhelming. I will say, even though I've used, for example, boards like the Arduino Uno for something like 15 years, I've used probably only a fraction of this. Like, you really don't need all of these things. But what's important to realize, and I think the only thing I really want you to kind of take away from this image, is every one of these pins, these little plugs on here, or even these little circles, these little pins, the way the circuit playground has them, every one of them has a whole list of functions that it can do, right? They have a whole list of capabilities. It's not just their simple input-output ports. I mean, in a certain way they are, but they also have the ability to do much more complex things. And we'll talk a little bit about the kinds of signals and the kinds of things that they can do and the kinds of communication. But fundamentally, those are pins that electricity goes in and out of, and then we interpret that electricity, or we send electricity out of it. But pins are a pretty important thing to wrap your head around, because you'll just see them referred to a lot. It'll be like, oh, pin 14. And it's like, what does pin 14 mean? And then I can look here and I realize, like, oh, actually an Arduino Uno doesn't have pin 14, so I'd be in trouble. But pin 13 would be this pin right here, as an example. And so some of these things will become more clear as we get into hands-on, but that is something I want to talk about as the basics of the hardware. Now, on the software side of things, it's a little more complicated, right? Because there is kind of very low-level, like kind of low-level foundational way to program these chips that come from the manufacturers of these chips. And if we went back to that really complicated document that we were looking at that describes the properties of the microchip, it would also, I'm pretty sure there will be a section in here that describes the logic of it, or how it thinks, or here's some like low-level assembly code to be able to write assembler and do logic on this by accessing registers, things like that. That is available and it exists. I never do it. I mean, I don't think I've ever written assembly for a device like this. I've almost never written assembly, period. It exists and it's down there. It's sort of the very foundational way to describe what this hardware should do. But the same way with the hardware, as I was saying, you know, we have these layers of things built on top that engineers have built to kind of help us interface with it. It's also true with the software. So nobody in this room need worry themselves about, you know, whatever, these different assembly, this assembly logic to write code to make this do something, or even the C code. I mean, when I'm working with these, I'm usually writing C++ through the Arduino interface, but there's even higher level, easier ways. And so I think that's an important thing to understand as far as, like, we talked about this being the brain. How do we get it to think? Like, what are we gonna, how do we tell this what we want it to think? And there's a lot of options for that. And the main one we're gonna look at today, which I think most of you already have on your screen, is the Adafruit Make Code interface that gives you a visual way to start building some of this logic, which I think is a really fun, interesting way to get started. I just want you to be aware that that is a convenience layer that's at the top that you may run into limitations. So there's always another layer down. You can always go a little deeper or get a little more complex. The one thing I would really like to point out as far as Arduino, and this is just to add to the confusion of what the word Arduino means, in addition to being this little device, Arduino also has an IDE, which is a development environment. And we don't need to go deeply into that today. I think some of you have even already used this, but it's basically a development interface for writing code to run on this. And it has its own sort of support system to make it a little easier for you. So just like we talked about, people went through a lot of trouble to make this easy for us to use by adding USB, by adding various other inputs, outputs, voltage regulators to make our lives easier. The Arduino IDE has done a similar thing for software, where if you're new to programming or it's something you're just, you know, you have a little bit of experience with maybe processing, for example, you can get into writing code with the Arduino IDE. And the thing I like most about the Arduino IDE, or just the Arduino software platform in general, there actually are other ways to write code in it, is code that you write for Arduino will run on all three of these. And so if you learn to use the Arduino IDE and you learn the foundations of Arduino code and kind of their sort of syntax structure, you can write code that will run on an Arduino, on a Teensy, on a Circuit Playground Express, because it is a pretty well-established, well-liked standard that will go across a lot of different boards and platforms. So I will just say up front, for the work that I do that involves microcontrollers, even very professional work, installation work, things that are going to travel around the world, I write that code with Arduino as the foundation. So it's not just a beginner thing, like the Arduino IDE and the surrounding kind of platform is very robust. And if you invest your time in that, it's something you can go forward with for a very long time. Whereas in my opinion, make code is great as an intro, but you might kind of eventually hit some limits on how far you can go with it. We're going to talk a little bit more on this, sorry, and then we'll just dive right into a few more terms, and then we'll get into looking more closely at the circuit playground. But I do want to talk about these boards, and if it seems like I'm spending a lot of time on this, I think something that's important to me for all of these things that we do at SETI, whether it's with hardware, whether it's with software, programming, electronics, there are a lot of different companies and platforms to choose from, and I think sometimes it can kind of come across as, if someone in my position sitting here in front of the classroom talks about one piece of software, it seems like I'm specifically endorsing that particular one, or that it's the right way, or it's the way to do things. And I want to be clear, all of these boards that are in my hand and a dozen other boards are totally valid. And there would be different situations where even I would make different choices for them. So I do want to be clear that none of these is the perfect answer. I think that some of you may find like you really like, you may find you really like the Circuit Playground Express because it does everything you want it to do, or you may find like, oh, actually, I find that pretty limiting, and I want to do my own stuff and add my own hardware to it, where that maybe would make you choose an Arduino. So just to run through these quickly, I already pointed at that Arduino website. I think it's worth looking at. I put first in quotes here because obviously, even in the 70s and 80s when I was growing up and my brother was growing up, there were lots of, you could go to Radio Shack and get like at-home electronic circuit kind of playground, very analog circuit playground things, and they were fun and they were interesting. So Arduino didn't invent the idea of at-home circuitry. And of course, that's a hobby that has existed broadly, even with programming microcontrollers like this. People would do that as a hobby even back into the 70s, but, well, 80s at least. But the barrier to entry was a bit higher, the tools were more complicated, and so really Arduino, I think the first Arduino was around 2003. It was built in the mold of processing, if you're familiar with processing, which you probably heard of in some other contexts at SETI, which it was kind of built as a tool to like get people learning, where you could learn, but you could also do real stuff. So it's not just purely an educational platform, it also really works. And so I think it is a very good learning tool, especially if you are interested in writing code. Because it's been around for almost 20 years now, there are so many examples, so many amazing projects that you can look at and see the cool stuff that people have done with these. You can kind of click the Arduino website and see things like that. The one kind of downside to them is options can be overwhelming because there's a lot of different Arduino boards. I still think of personally, and maybe I'm just old school in this way, I still think of Arduino, the Arduino Uno R3 is still to me the canonical Arduino board. Now they have so many new ones that have like built-in Internet of Things capabilities where you want to talk to things over a network. That's all great, and that is totally available to you. But I still think of like just physical computing, you're going to make hardware, do fun stuff, the Arduino Uno. But they do have many, many options, and I do find it can be a little bit difficult to navigate. Oh no, is my link bad on that one? Let's try that again. That's what happens when I don't test all my links before we talk. Oh no, okay. What have I done? Oh, that would be the problem. Okay, if that one didn't work and you're following along the workshop sheet, you can just go to arduino.cc. But you can see if we start looking at the hardware and we look at the boards, there's a lot of them. So we can look even in the classic family, the sort of old school version that I'm talking about. There's a whole range of them that have slightly different options, different capabilities, more pins, less pins. Some of these have features that others don't have, and it can be a little daunting. In my mind, again, the Arduino Uno R3 is classic. The Teensy, as I mentioned, is made locally in the Portland area by PJRC. It is pretty astounding how powerful this device is. It's basically, especially the Teensy 4, these are close to, I mean, these are basically cell phone class processors in terms of their capabilities. So these aren't perfect numbers to go with, but just when you see the 600 megahertz, that's the clock cycle, that's kind of, for lack of a better way to put it, that's how fast it can think. And you look at these other older Teensies and see that it's only 48 or 120. So you can just look and see even though this isn't a one-to-one sort of performance metric, you can just see, oh, the clock speed of this is just an order of magnitude faster in some cases than these other boards. So they can do pretty incredible things that would be difficult to do with these other boards because they require so much processing. So things like dealing with really complex audio or really complex driving of hundreds of LEDs, for example, would be quite difficult to do only with an Arduino. You can. Usually you would use your Arduino with a few other pieces, a few other components, but a Teensy can do a lot of those things just built right in. It is Arduino compatible. It's kind of a funny thing that we won't go into today, but Paul has basically hacked the Arduino ID to support his boards. So you do actually have to go through some kind of silly instructions to be able to program it, but all those instructions are online. We won't worry about that much today. As I said, it is created by an extraordinarily talented local engineer who is part of the SETI community. He does show up at different workshops, so he's an amazing resource to just have locally. The one downside to it is I think it can be a little daunting for beginners because it is so powerful and has so many capabilities. It can be a little intimidating to start with, but you can run many of those standard Arduino examples and jump right in with it. And then, as I mentioned before, repeatedly at this point, the Circuit Playground Express, which is the one that we're kind of tentatively saying like, okay, this is what we're going to use at SETI to introduce people to these concepts because it has so many things built right in. It's pretty amazing how many sensors they built in this board. And we'll talk about that in detail today because I think that is actually one of the most important parts of this. There's also Adafruit, which is the company that makes it, is a really incredible company, just sort of in the broader kind of like hobbyist and maker electronics world. They have so many different kinds of kits and tools and fun LED projects. And so if you're not familiar with Adafruit and you're interested in making things with technology, it is definitely a place to look. I think they're New York based. They design much of this in-house and handle the fabrication of it. They do sell other things that aren't just kind of their own pieces. But to me, what is the biggest value to me with Adafruit is the hardware that they design and then sort of the broader support network they have around it of tutorials and examples to get you started. So I'm a big fan of it. There's some things I'm less a fan of, like this word right here, CircuitPython. Not as much a fan. Some people may enjoy that. If you have Python experience, you might find that that is a bit easier field of entry for you. I wouldn't personally recommend it, but you do have lots of options. Now, the one downside to this that I would say is that because it is so easy to get started and it's so easy to have it so like totally self-contained and simple, that once you start to want to do things that are more complicated, you may find that it's a little difficult. And you may find that it's a little difficult to do that because of the number of inputs and outputs is relatively limited on this. You may find that it's hard to do it just because of the form factor of this. And that is why, I mean, personally, I have a hard time imagining that I would ever use this in a project because it's hard to integrate into a project because it's a circle and it has these big holes. And when you're designing, for example, a circuit board, as an example, very frequently, the project I will use something like a Teensy, and then I will design a bigger circuit board that the Teensy just plugs right into it. So here's an example of what that might look like. You can get these little Teensy breakout boards. Is that the right one? That's not what I'm looking for. That's for feather. That's not what I want. I think we want something more like. There's some really good ones that have tons of features. Maybe this would be a good example. But the idea here is once you get further along this journey and you're starting to design your own circuit boards, fabricate your own circuit boards, build in your own connectors, your own sensors, your own technology, it's nice to just be able to plug a Teensy in as the brain. And so I do that very often. A lot of the projects I've worked on in recent years, I will design the circuit board, have it all set, built totally my specifications for the project I'm working on. And then all I have to do is just plug a Teensy into it and program it. And then I have that as sort of the brains of a bigger project, which it's because the Teensy is designed to kind of fit into that sort of ecosystem. I mentioned those pins can kind of slot right down. This little Teensy is that thing that's plugged in right there into the bigger chip. Sorry, the bigger board. That would just be difficult to do with something like this. Definitely not impossible. I'm sure people do it. I'm sure people figure it out, but it's just not a choice that I would make if this needed to fit into a bigger piece. Now, I'm going to bore you with only two more terms, and then we will start looking a bit more closely at this thing. But these are two terms that I think are important to have some notion of. And some of them, I'm sure you've heard these, like digital versus analog in other contexts. I'm going to speak about it very lightly because it is kind of foundationally the two different ways that information will come in to these devices and go out of these devices will be either a digital signal or an analog signal, right? And so if some of you have experience with programming, or maybe if you have experience with audio synthesis, or even like film or television or broadcast, you might have some understanding of what these mean. But we'll just talk about these briefly. In this context, when we talk about digital, I'm sure it's a word you've heard a billion times. In this context, we're specifically talking about a binary yes/no question, basically. And that is all we can express. So, as humans, we have a numeric system that counts up to 10. We call it base 10, and it's probably because we have 10 fingers. And so we can talk about kind of 10 things. In a binary computing system, you can only count to 2. You have 0 and you have 1. And that's as high as you can count. And then if you need to count more, you just need to keep adding zeros and ones. It's the exact same concept as if we're counting in decimal, where I would go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then now it's like, oh, I can't count past 10 unless I like use a toe or something. Or I make a mark on a piece of paper. With a computer, I can only count to 2. Very often, that's as high as we need to count because we only care about a yes/no question. And so just thinking about that one yes/no question. So for example, this button on here, is it pressed? No. Now I pressed it. Now it's a yes. So what is happening in terms of the electronics, in terms of the circuitry, in terms of the brain that's here? In the binary representation of that, 0 means no, 1 means yes. And I'm sure you've all run into that in like movies or TV or culture broadly, like thinking in terms of binary zeros and ones. It's really not more complicated than a yes/no question, right? That is what it means in binary. So on the computer, somewhere in here, there's transistors that are flipping, that are on or off, yes, no, right? Then we have sort of our logical reasoning about that, right? So it's a yes, no, it's a true, false, it is or it isn't. That's sort of a reasoning thing that's separate from the physical transistor. And we call that the logic, and that is where we say true or false, right? So again, 0 is no, it's false, 1 is yes and true. So I think most of you probably have a pretty intuitive understanding of that. The place where you may not be familiar, or the part of it that might be new to you, is how you describe that with electricity. And it's kind of a deep topic, and so I'll just say the very simple way, especially in these contexts, is if there is no electricity, the answer is no. And that's the very simple way to think of these circuits. It's really as simple as if I unplug the plug from the wall, the answer is no. And then if I plug the plug in, the answer is yes. If the button is open, the answer is no. If I press the button is yes. And so what that actually means electrically actually is a little bit different between these devices, because these devices have different what is called logic levels, which is basically just the amount of electricity they use to think. And we won't go too deeply into that. But yeah, the way to basically think about it is 0 electricity is false, it's 0 in this particular case and in this particular case, but not in this particular case. 3.3 volts means yes. And that's a topic for when we go into electronics. I think Nandini will do a bit of a talk about the basics of electronics, but all you have to know is there's kind of 3 ways that we think about these yes/no questions. We think about them in terms of voltage, in terms of sort of their logical implications, and this 0/1. Now, as I mentioned, if you can only say things in yes/no questions, like how do you express complex data? And that's a bit of a topic for another day, but you can start to imagine if you've seen kind of like, I'm sure you've seen this in movies, that it's like, what is my name in binary or whatever. And there will just be some standard, for example, Scott, convert the binary, and now you can see a representation here that is a bunch of 1s and 0s, and it's a bunch of yes/no questions. This is for a specific kind of encoding, and so I think it is important to understand there's nothing really about this that is an S. It's really, this is a number that refers to an S. But my point here is to say Scott, those 5 letters, it takes us a lot of yes/no questions to describe it. In fact, every single letter that we see, very often, certainly within an ASCII representation, And the letter S, for example, it takes 8 yes/no questions for a computer to understand the letter S. And so all I want you to kind of understand is when you're dealing with this yes/no, you can describe anything. And basically anything you see on your computer, any song you listen to, video that you watch, any representation of data on the computer at some very low foundational level is really just a whole lot of yes/no questions. And when you hear a file described as like 1 megabyte, and you're thinking like, well, what does that even mean? Like, what's a byte? A byte is 8 bits. So a 1 megabyte file is 8 megabits, meaning it is, what's that, million or billion? Million. That is 8 million yes/no questions, and that's all it means. So when you see a file is, 1 megabyte, that's just 8 million yes/no questions to describe what's in there. So that's a big topic, I know. I just want to like set the foundation of understanding. That's kind of how computers think. Yes, no, yes, no, yes, no, yes, no, right? There is another way that computers think, and this is a bit more old school, and this is a bit longer term, and this kind of predates the very full digital era we're in, but it is still an important thing that we use often. So the very simple way to put this is we talked about digital input is just yes, no, the light switch is on or off, right? When we're talking about analog input, we're talking more about like there's a dimmer switch on the light, right? Or there's a knob that you can turn it up and down. So it's not that I just walk into the room and I flip the light switch on or flip the light switch off. I can turn a knob and it's dark and it gets brighter and it gets brighter and it's brighter and then it's dark and it gets darker and darker, right? So it's a range of values. And there's actually a lot of ways that you can turn knobs to affect a circuit, and very often you're actually affecting resistance and not voltage. But in this case, we're specifically talking about there's an amount of electricity that is going up and down, like this kind of little chart here, and we're able to recognize that, right? So either there's no electricity or there is whatever the logic level is. In this case, it's 3 volts. There's a range in between there, and that's how I know what the temperature is, or what the volume is, or whatever that I'm reading in as an analog signal. So thank you for bearing with me on that. A lot of those things will hopefully feel a little more intuitive as you start to play with them. But now let's look a bit closer at this actual device. Let's look a bit more closely at the Circuit Playground Express and talk about its capabilities for the fun stuff you might want to do, things you might want to play with. And so I don't want to go crazy on this because I think it actually is better if you just play with it and experiment with it a little bit, which I see some of you are already doing. But I do want to briefly talk about the options for programming it. So that very simple one is the one we talked about briefly at the start. To jump in is make code, where you're just like plugging blocks of logic together. And I think it really is a really great way to just dive in and experiment with these kinds of things. You also have the option to write code. Make code. So actually, once we're in make code, you will see there's a little button at the top that you can switch into JavaScript mode. I'm just going to say right now, I'm relatively new to the Circuit Playground Express. I think it is interesting for beginners. I don't know that I would recommend the JavaScript part of this, because I guess my opinion is, well, if you're going to write code, you should just write code, and you should just go to the Arduino IDE. So I could see it maybe being useful where if you're just learning this and you're using their block-based tools, these like initial block-based tools that they have for kind of like dropping in inputs and outputs, they will let you do this and then go look and see if I can get it to work. Oh, that can't go in there, obviously. Let's just put a random thing like the light. Once I do this, and I have this thing that's just going to make the light red forever and be kind of boring, but that's fine. So you can see the light's just red. That's all I've done. The light will be red forever. You can click here and see the JavaScript code that does that. It's just red, 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 red. If that is a comfortable way for you to learn, you can kind of make the transition from this into this. It's just, in my opinion, like if you're going to start writing the code, I would personally say Arduino, you will have so much more power and flexibility there, but it will be a steeper learning curve. But those are both options there. They also mention on the page we were just on, if we can find it again, the option to use Circuit Playground, which I believe is, Circuit Python, which I believe is a fork of MicroPython. I cannot think of a reason to recommend that to you unless you already know Python and you like Python. Would be kind of the only reason I would recommend that. Like if you're into Python, that's fine, and if that's your comfort level, you can start to look into using that. I would otherwise say start with the block-based code or just get into the Arduino IDE. And really, I think everybody today should just play with the block-based thing just because it's fun. Now, putting the software on this, we'll go through a quick demo of that in a second because it is a little finicky. And it's kind of cool the way that they do that, but it's a little bit different than you might see in other contexts. But the main thing I want to review quickly, and just I'm going to go through these kind of rapidly, one, because they're literally here, and you don't need me to read web pages to you for the most part, I hope. But also because, well, my hope is that, maybe, I'm going to run through these to put them in your mind, and then maybe there'll be some things if you have questions about them that I can explain that are not necessarily represented in the documentation, but I do just want to talk about, like, what is this thing capable of? Like, what can you really do with it? So, as I mentioned before, micro USB, that just means you can plug it into a computer. What is cool, though, is this little line right here. And if you're not familiar with that term, HID, that means human interface device. And what is really neat about that, and to me, one of the most powerful things about this and this, but not this, actually, this can't do that, is this can pretend to be other kinds of hardware plugged into a computer. So you can make this pretend to be a mouse and plug it into a computer and then tilt it around and control the mouse. You can make it where these buttons play the mouse buttons. You can make it where you had some fun drawing tool on the screen and then you had a glove on and you could tilt your hand to draw, whatever you want, because you're essentially emulating or spoofing mouse input from this device, and the computer won't know the difference. The computer will just think a mouse is plugged in. So that to me is one of the coolest features of this device. The Arduino Uno can't do that. Other Arduinos can, but not the Uno. And in fact, I'm not sure of the full list. The Teensy can emulate just almost anything you can imagine. It can pretend to be a joystick or a flight stick. It can pretend to be a MIDI controller, so it can show up to your computer as a musical instrument, which is really cool. So that to me is one of, if you're making things on your computer, you're using Unity, you're using processing, you're building murals or installations, it can be really powerful to just have this thing act as a keyboard. And in fact, I think I had, let's quickly find that particular example from last week.
So with the Teensy, could you like hypothetically make haptic gloves for VR?
You potentially could. I think you could. The only trick with that is that the VR specifications might need custom drivers. I mean, just so in other words, those may not be straight human interface devices that are totally standard like a keyboard or a mouse. So you might have to do a little extra work to do that. And also normally, not always, joysticks sometimes have rumble and things like that. So maybe you could trick it into being a joystick. So it would be a little more challenging, but I think it would be possible. But I even use it for the dead simplest things sometimes. So I think I showed this last week. I'll just show this video briefly. So this was an interactive kind of musical mural that I did at the Children's Museum in Pittsburgh. And the idea is that there's this musical mural projection. There's these physical ropes that you pull. And you can see when I pull the rope, you can hear it play some simple music. When I pull those physical ropes, I think this is before I added the ropes that went to the screen. But you can kind of see up on the screen itself, there's a continuation of that rope. And in the final installation, there was rope that went on. And so when the kids would come and play with this, it would look like they were grabbing a real rope and pulling it and then seeing the cartoon rope move. And the entire way that that worked was so simple. It really was just clicking keyboard buttons, basically. So it wasn't a complex circuit at all. I think I even have a picture of what the prototype looked like, which was very silly. Is this it? That's an older one. Yeah, so this is the prototype. This is the prototype to do that. And so these are just a certain kind of button. And so I just had it that when you pull the rope, it pulls on this spring, this little washer, push this button. This is the prototype. The final version was much fancier. It was designed by one of the engineers at the museum. So my version is not the one that went traveling because it probably would have broken as soon as the kid hung from it. But you can see it really is this rope pulls this spring, this washer comes in and pushes this button. And then the microcontroller here, which in this case is an Arduino Leonardo, which can do that human interface thing. And so all that happens is when one of those buttons gets pressed, I pretend to be the keyboard. And so I hit like the A button on the keyboard when it's pressed, and then it's released, I hit the Z button or something like that. And then my software only needs to know how to have keyboard control. Oh, 100?
So, answering his original question, someone has already made.
Oh, really cool haptic gloves. Oh, cool. So maybe when we go into the other session, you can check it out. I mean, people have made so many, almost anything you could name, probably somebody has some version of it. I always like check out Instructables and sites like that to see. So, yeah, so you can, in this case, it's so simple because all I'm doing is I'm telling this device to pretend to be a computer keyboard, just like this keyboard you see connected to these Macs. It doesn't know the difference. And so I can do something, you know, the kids have no idea on this. They just see this kind of like magical mural and they go and play and have this kind of magical invisible technology experience. Let's see it. Probably some kiddos playing with it somewhere. Those aren't kiddos at all. Anyway, so you can see, and they play with it, and they can hang on it and kind of swing. And that was one of the more complicated parts, was to make sure that you could have 4 kids hanging on this without it breaking and collapsing. But the fundamental, like internal electronics of it, very, very, very simple, and just made with a very inexpensive. I think an Arduino Leonardo is under $50. They're very inexpensive devices, and now this is out traveling all over the country, and it's used by probably thousands and thousands of visitors at this point, and it's all just one of these little devices. So I think that's really cool that you have that option to kind of do interesting human-computer interaction kind of beyond the normal expectations of human-computer interaction. It does have battery input, which is cool because one of the things Adafruit does a lot of, which is neat, is wearables. And so something that's pretty slick is that, and that is nice about these big holes that I personally complain about, but lots of people really like them, because if you're doing soft circuitry, you can use conductive thread instead of wire. And so then you can put this on a glove or make a little brooch out of it or something that you want to wear. I actually saw one yesterday where someone put it in their face mask and had their face mask illuminate kind of with an Iron Man kind of thing. Or I've seen people put it inside their shirts and kind of illuminate through their shirt to give them the Iron Man, what is that called? His arc reactor, is that the right term? To kind of make a quick little Iron Man thing like that. And you can, this is very friendly for that kind of thing because it does support battery power, and it is pretty friendly for those kind of soft circuitry, conductive thread kinds of projects. It also uses alligator clips. Then make it in here without using alligator clips. We'll look at some when we go back to the lab. All an alligator clip, if you're not familiar with, is just it's kind of what it sounds like. It's just a little, it's a wire, and one end of the wires has these little metal chompers on it. And so these are great for if you're just experimenting, you're prototyping, you want to like, okay, I want to plug this and I want to hook this to some LEDs, I want to try this. I use these all the time for that kind of prototyping. More so, me personally, and that's another reason I'm not a huge fan of this board, is I use breadboard prototypes all the time. Yeah, so a breadboard, and we have tons of breadboards in the lab to play with, where you have, this is called a breadboard. Yeah, and it's very common to set up circuits like this. And so this is another way to do it. And that's another reason that I really love the Teensy, because you can just plop a Teensy right in the middle of the breadboard and start hooking things to it. And Arduino, as you see here, sorry?
What do I call a breadboard?
I don't remember the term. There are so many. Do you happen to know what the origin?
They literally used breadboards back in the day. So they would put nails into a breadboard that you would like cut bread on.
Oh, physically, wood, like a cutting board.
Yeah, so they use nails to connect them electrically, and then they got updated and better over time. But the name stuck. Cool.
Oh, I didn't know that origin. That's really funny. Yeah. Thanks, Miguel. So yeah, I mean, old school, you could imagine you could do the same thing if you just had a cutting board that you drove some nails in and started hooking wires into it. In fact, like old school wire wrapping is such a beautiful, it's kind of a lost art, I guess. Like the way people used to do, I mean, there still exists in the world. I'm sure we can find some like, the ways like early prototyping and early board, they're just like almost beautiful looms. The way, I mean, some of them are less pretty than others, but really interesting kind of wire routing. But this is still, so yes, you can still do this, of course, but a breadboard makes life a little easier because you can just kind of poke a wire into it. But this one is designed not for it, it's designed for alligator clips, although we do actually have alligator clips that are alligator clips on one end and then have the little breadboard friendly connectors on the other end, so you can kind of have the best of both worlds if you want to hook it all together. So we were going through our sensors. Sorry, I keep losing my page. Okay, we're going to breeze through these. There's some microchips on here. As I said, in this case, this is the brain of this chip. It is quite powerful, especially relative to this one on the Arduino. You know, it's definitely not quite as fancy as this one on the Teensy, but it's pretty impressively capable. And it's able to manage all this input and output and do the fun stuff that you want to do with it. So it's a pretty powerful board for being so inexpensive. I think they're about $35. Depending on which kit you get. It has some simple built-in LEDs. These two are kind of, I mean, obviously the power light is the power light. That's not very exciting. You do have the ability to flash this red light, so it's a pretty common thing. Just as a rule of thumb, I usually turn, like all of these boards have kind of that pin 13 light, and I just do that as proof of life sometimes when I'm making things. But what's really cool about these are they have these 10, what they call neopixels, and that's kind of their brand name for them. But what they really are is addressable LEDs, meaning you can talk about any one of these LEDs and decide what color you want. So you have like your cool little color race there because you're able to address these individually and tell them to do different things.
That's what it was starting with in the first place anyway.
I wonder if someone, I don't know, maybe somebody programmed that. I bet someone last week had that same one and already put that on. But we'll go through soon and look at some other options for that. So it has a admittedly terrible speaker on it. So it's pretty awesome that it has this cute little speaker. It is pretty bad, but it is possible. This little pin here, pin 0, there's me using that term pin. So if you look down here, you can see all the pins are labeled and there's all this info all over the place. And hopefully you can find one that says pin 0 and it will have a little zigzag next to it. And that means you can actually connect headphones to this, which is pretty cool. Or you can plug it into like some other audio system, speaker amplifier, something like that pretty easily. So we can probably, we'll take a look at that in the lab. And it has so many kinds of sensors. So I mentioned last week that it had a light sensor. I said last week that I wasn't actually sure if it was a photoresistor or another kind of photocell. This is actually a phototransistor. We don't need to go into the differences, but they actually link you to the individual part numbers. So you need to know how that thing works. This is it. It's a teeny tiny little ambient light sensor. And actually, you know, a similar device is on your phone right here, so that when I put the phone up to my face and I'm talking, it can know that I put it next to my face, and usually the screen will turn off because it has a tiny little ambient light sensor up here at the top. Many phones will have those. This does have a built-in temperature sensor, so you can get the temperature. I'm not 100% sure how accurate it is, but it does have the part number for that. It has a microphone sensor. Now, something interesting about this microphone on here, we talked about the differences between digital audio and analog audio. Often microphones are analog, meaning you're actually getting an electrical analog signal from a device. This is actually a digital microphone. So it's actually communicating with a bunch of zeros and ones. We have a motion sensor here. So, you know, I showed that frame that you could tilt the frame and things would follow around. This can detect tilting. It can detect free fall. It can detect shaking. There's lots of kinds of gestures it can detect. It does capacitive touch, which I think last week, I mean,
There's a reset button.
there is a reset button, yeah. So that's kind of part of the programming. Yeah, there in the middle is to reset the device. The capacitive touch, I'm sure some of you who were here last week saw this project, but just to kind of show some capacitive touch in action, you do have the ability, this is kind of my first big capacitive touch project. You have the ability to kind of create experiences where you can touch a thing and have the computer recognize it. So in this case, I'm using physical real beats from the grocery store as capacitive sensors. And so you can plug a capacitive touch electrode into something. Pieces of metal work well, beats work okay if they're a little bit wet, and then you can detect that touch. And so we'll kind of look at that today. It's fun to make like a little piano by running copper tape and things like that. What else? I keep getting lost. A few others, there's switches and buttons. So these, like I mentioned, the switches kind of like are on the piano plug. You saw the reset button. So the reset button is actually part of the programming of this, and we'll run through that very quickly.
So now no longer has that wrinkle thing.
Okay, well, so you're in programming mode, so that's good. So we'll talk about that in 1 second. That's actually how you tell it that you're ready to put your own code on it. And then it's got a cute little slider on here. It's a little hard to see, but it's right here in the middle. There's a little switch. You can switch back and forth. And then the last thing it has on it, I talked for a while last week about how a very common, maybe a little less common today, but certainly within the last few decades, way for electronics to communicate. Like this remote control and that projector communicates with infrared light. And I talked about how I did a project where I used that to detect my heart rate. There actually is built in here a little IR transmitter and receiver. And that's cool because you really could, with a little bit of work, we could make this device turn the projector off. Or you could go into a Best Buy and turn off all the TVs if you knew what signal to send here, which I'm sure is online somewhere. You can also use it for two of these to talk together. And you can also use it for proximity detection. So you can kind of see like how close or far something is by shining out IR light and then looking at how intense it is when it bounces back. And again, I was talking about how that kind of, I mean, in fact, you know, I said before that that was an ambient light sensor, which I'm pretty sure there is an ambient light sensor on here. There may also be IR for the face proximity. So it may be a combination of two sensors because I think there is ambient light. I know this shines IR on an iPhone because that's how it's illuminating my face for the Face ID. But I can't remember if it has an IR receiver on this as well. Many Android phones do. I just don't remember if an iPhone does. And then the next piece, and this is where it gets deep, and we just don't need to go fully into this, is like the full pin out to like really look at what the individual pins are capable of. And so if I look at this board, for example, and I see this thing that says A6, like what is A6? What can I do with A6? And I can look and I can see it can be used for digital input or output. It can be used for analog input. It has PWM output, which is called pulse width modulation, which is a topic for another day. It has serial receive, meaning it can receive sort of streams of information from other hardware, and it can be used for touch. So I should probably stop talking and stop being so boring, and then we will just, let's look at the code interface, run through one or two quick examples in here so you can just kind of see how to go about using this device, and then we'll take a quick break, and then we'll just spend an hour up to lunch or an hour and a half, whatever we have left. We'll just go to the lab and play with these examples. And I'm sure some of you it will be easier if you just kind of follow the examples one by one and try the different examples. Some of you, I'm sure, are already off to the races back there. I see some blocks on some screens, so I assume that some people are already up to doing fun stuff. So if we go to that makecode.adafruit.com, and we start here, and we have all the projects, and you can see these things I started, but I'm just going to start with this new tutorial, this siren tutorial. So if you want to find that on the page and click and go in there. And right down here, you'll see Start Tutorial. And the way their tutorials work is a little strange, but just to describe it, it kind of walks you through the steps one at a time. It doesn't do them for you, but it will kind of walk through the steps one at a time. So is everybody able to get to this page okay that wants to be on this page? This kind of siren example where you can see these dots across the top. Looks like everybody's doing good. Everybody okay? Great. So I should actually plug in my device so I can do this with you. Although, again, the thing I think is really cool here is that it will, there you go.
I'm going to watch this because I don't want to put it in.
Yeah, that's fine. No, we will have plenty of time to play after this. So you can definitely watch here. Now, and again, one of the things I think is really cool here is, oh, how funny. Your little thing in the corner is not loading yet. I wonder why that is. I wonder if this could be a Chrome versus Safari. No, I meant Safari. Maybe try to refresh it and see. Okay, it came back. So Roberta, you might need to just refresh your web browser.
I mean, that is Chrome, and that's and you're using Safari, not using Safari.
Yeah, so you're right. I think it is.
Delete, click these boxes.
Yeah, thanks, Dave. So I plugged this in, and you can see I've got the little fun little rainbow racer startup thing here. Now, one of the things that I think is really nice about this particular device, especially if you're watching this at home and you don't have one of these yet, everything this can do, you can kind of do an experiment with up here in the corner and see it kind of respond and react. Are you still not getting there, Roberta? Oh, thanks, Miguel. Yeah, if that machine's being finicky, it would be easy to move next. So, okay, so let's just go through this first tutorial together. It's dead simple. But we'll just kind of walk through the steps of it, and then hopefully, yeah, the browser thing. So the idea with these tutorials is you can see up here at the top, there's a series of numbers, and definitely don't worry about keeping up because you can go through this at your own pace. But the way they do it is they kind of walk you through the steps. And one of the things that's really nice though, is as they tell you instructions, if you just put your mouse over the instruction and kind of click on the highlighted parts of the instructions, it will pop up and give you a hint on what you need to do. So for example, right now, and everybody's welcome to follow along, it says go over to input. And if I don't know what input means, I can click it and it will kind of show me. And get the on shake block and put it in the workspace. So, and again, I can click on these and get a little hint on what it wants me to do. So I'm going to go over to input and click input. And I see this on shake. And that is in programming, kind of programming logic terms, I would refer to this as an event, right? Meaning on shake. Somebody just shook this thing. What are we going to do, right? So it says find a show ring block and place it inside. And so the whole way this sort of block-based programming works, oops. Okay, show ring, great. Okay, now I'm gonna click on light. So it says find a show ring block. And now I'm just gonna drag this out here first, but it's saying to put it inside the on shape. So you can see here I have an on shape and I have a show ring, and you can see it's got this like little jigsaw piece. I can plop it right in there. And now I'm saying anytime I shake this device, show this ring, right? So Roberta, if you click on that pink side where it says input right there, yep. And you can just drag that over to your workspace, yep. And now if you click the blue spot where it says light, yep, drag that whole thing over and you can kind of drop it inside there. Yep, exactly right. So is that working for everybody? You kind of see how you sort of snap these together like puzzle pieces. Now, the part about this that is really cool, and especially for those of you at home who may not have one of these yet, up here you see on my little circuit playground, it says shake. If I click that, it will pretend to shake. It will emulate a shake. And if I click it, you should see these lights turn red. It should actually do the thing. So yeah, Roberta, up on the actual board itself, the picture of the board in the corner, no, in the upper left, sorry. Like the actual drawing of the board. Yeah, you can click that shake button and it should turn red. Yep, you got it. So that's pretty cool. So we can kind of like simulate this before we actually put it on the device. But let's continue through the instructions. So going to step 2, it says use the color palette to select a color. You pick one of the colors from the middle of the ring and you go around and set them. So this is kind of a weird way to do this, but in this example, I'm going to click the blue here out of this little slice of pie. Click blue. You can see that I have blue selected, and now I can just go around and click all these, and it's going to make a fun popping sound. And I've set them all to blue. So again, you pick the color from the middle by clicking the color, and then you just click the dots, and that's just how you're going to tell it what color you want the lights to be.
If you don't want the lights to be on, you just click the thing in the middle.
Yes, you can totally cut them out. I think you can also toggle them. That is absolutely right. So it's suggesting that we change them all to blue. Now, however, I will tell you my personal style. I almost never follow tutorials exactly. So definitely feel free to, if you don't want it to be blue and you want it to be purple, make it purple. If you want every other one to be blue and purple, definitely do that. Everything okay?
Yeah.
Cool. And so now if I click shake, you can see all the lights are blue. So the instructions that I'm creating, the code I'm creating, the logic I'm creating is simulated here. And then we'll show you in a moment how to actually put it on the device. Okay. And it's going to be loud and annoying, and it's going to be kind of funny, and that will probably be a good time to stop the stream. So going along the instructions, the next step says we want another show ring. So we're going to go back to light. We're going to drag this one in, and now you can see it says basically show a blue one, then show a red one. And if I click shake, it'll be blue and it'll be red. But it's only going to do it one time. So blue, red, right? And I'm going to kind of breeze through this because it's like people are starting to get the hang of it. And again, if you need a refresher, you can click the highlighted buttons and they'll kind of help you out with what to do. So the next thing is a very fundamental foundational idea in programming is the idea of loops and looping, meaning you want to do something over and over again some number of times. And so you can see right now when I shake it, it's blue and red, and then it kind of stops, right? It's a little bit boring. We want to do it a number of times. So I'm going to say repeat 4 times. Now, the thing that's a little tricky about this is I actually want to kind of make a sandwich here. And so you can kind of see with my logic, I'm saying on shake, anytime there's a shake, repeat 4 times, turn blue, turn red. And so now if I shake it, it should go blue, red, blue, red, blue, red. See, is everybody kind of following along? So Roberta, I think if you can, you might have to close that little window that popped up by clicking back. Or I think if you just click input at the top where it's pink again. Yep, I think it'll go away. Yep, and now if you click your light button again, yep, just drag that red one in underneath the blue one. So you might kind of a little bit lower because it's going to want to kind of puzzle piece snap. So I think you have to get even lower. Yeah. It can take a little while to get the hang of. Yep, you got it. Great. And then, so once you have that, now you're going to click on that loop button. And you're just going to drag that around those. And so you'll kind of want to snap that puzzle piece actually on the on shape. So that puzzle piece is fitting in the on shape. Yep. And so basically, and this is, I think Nandini is going to do some more talking about this, the idea of like logic and algorithms and programming, but a loop just means do something more than one time, right? And so in this case, we're just saying, I for 4 times want to flash red, flash blue, right? Pretty simple. I feel like I should try to learn to turn the volume down in here before.
And then again, you can also make it turn off if you have like another.
That's right. And so I think one of the next steps. Is this actually like, or is there a volume? Actually, yeah. Is that turned down? No, not yet.
I thought you said something about it, but I wanted to check.
Oh no, sorry. Yeah. Once we go through this example, we're still. But thanks for checking. So, okay, I just don't want to be super loud because we're about to make some noise. So the next step will be, let's add some music. So we have this little sound section over here. And to be clear, this does a lot more than this. They're just kind of like keeping the list kind of short and simple while in the tutorial. So something that's important here, you know, I talked about the loop is something we want to do over and over again. We only want to play the sound one time. So I'm going to put the sound up here at the top. And it says, you know, put it outside the repeat block, so that's good. So it's going to play a little ba-ding sound, which is a little quiet for us, but actually, Miguel, sorry, would you mind turning that up just a little more? That was better, but just a little bit more. Thank you.
More down.
Up just a tiny bit.
I think you can also shake it by moving your mouse around.
I think so too. Yeah, let's try that. Because I think some of the things it will respond to, if I kind of, yes, thank you. Because it will, let's see. Yep, you're right. So it will actually interpret those gestures as well. So moving along, it says we want to change this, and we want to change this to the siren sound. I hear lots of sounds happening around, so I hope that's a good sign that everybody's following along. We're going to change it to this annoying siren sound. So let's try the siren. Okay, so we hear the siren, and now there's one last thing I think we need to do here, which is, and Brooklyn, you were commenting on this, we could either go through and set these all off individually by clicking this and clicking those, but they also have this idea of a clear button. And so we can just add clear after the repeat. So basically, now just to run through this logically like we were writing code, we're saying if there's an event where there's a shake, we want to play sound. And then we want to do something 4 times. And the thing we want to do is make the circle blue, then make it red. And then when we're done, we want to turn it off again, right? It's handy. I didn't know about it until like yesterday or something when I was first playing with it. So I want to pause here for just a moment and talk about what we've just done because it may not be obvious. We've written a program, right? So a program, if you're new to programming and new to computing and new to that sort of realm of computing, a program is a recipe. It's like you're saying, here's a recipe on how to bake a cake. In this case, we've created a recipe on how to blink a light and play a sound, and we're going to put that recipe on this device, right? So just like if I wanted to bake cupcakes, I would look up a recipe, I'd follow the instructions, and then in the end, I would have cupcakes, hopefully. I would hope I made the cupcakes. In this case, we're writing a recipe that makes a little police siren, and then we're going to give that recipe to this device, and it's going to do that. It's going to follow through the recipe. So as you can see here, if I click, I get it. So we're doing it in the simulator, so we feel pretty good, like this is working. And if you're at home trying this, you know, maybe just doing it all in the browser while you're still learning, you're done. You've kind of figured it out. But for those of us in this room who have these devices in our hands, we want to now put that recipe on this device. And so there are various ways to do that. The way this particular tool does it. I'll just admit I'm very new to. I've only like very, very new to it actually. It's pretty cool, but it can be a little bit finicky. So if you have trouble with it, don't worry. You can just like raise your hand, and Miguel can come and help, or I'll help. But if you get confused by it, but the speakers on them are quite terrible. So they may sound like a nightmare. So the next thing we want to do is click download to transfer your code to the Circuit Playground Express. But we're not downloading straight to this. It actually is 2 steps. So first I'm going to click download here, and that's going to download the file to my computer. So those of you that are using the MacLab Macs, you should in your downloads folder see, in fact, first I have to light it. So I've got this file that downloaded, and now I should actually have that little downloaded file here. So I just have that file that I downloaded in my downloads folder with who knows what else is in there, probably something embarrassing. Yes, there's some pictures of me in plays in high school that are very embarrassing, so we don't need to look at those. But I will set that aside. So I now have this file, this Circuit Playground Siren, which is just the name that was at the bottom, right? So I now have the file. So now the trick is we have to tell this that we're ready to program it. And so Brooklyn, you already found that reset button. If you click the reset button, and then we look in Finder, and sometimes, honestly, I'm still learning this. Okay, so I got it. So by clicking that reset button, and if you click Finder down here on your Mac, you'll see, hopefully, a little thing called C Play Boot. Is everybody seeing that thing? You drag this in here, you let go, and it should automatically program. It'll just go away, and it has automatically programmed. And now, when I shake this, it does the thing. So I can give it a little shake. I'll get the little siren. I hear other annoying sirens. So it seems like it's working. Roberta, it looks like you got it. Oh yeah, great. You got it. Brooklyn got it. Everybody else figuring this out. Seems like it's working. Everybody in the corner is doing well.
It's extremely sensitive though.
It is pretty sensitive. And we can talk about how that works because it's
Of course, as soon as I say it, it doesn't do it when I just go like this.
Well, so the issue is, and it's kind of interesting, is the sensor that is in use here is called an accelerometer. So it's not necessarily that it detects movement. Like if I was in a car and that car was going at consistent speed, it wouldn't detect anything. It only detects acceleration. And in this case, this is again one of the spots where someone's done some work for you. So they have written some code that tries to interpret what a shake is. But a shake is not it's a subjective thing. Like, what does a shake mean? It's like, well, somebody wrote some code and they're like, well, I think it means it accelerates a lot this way, and then it accelerates this way, and then it accelerates this way. But it's just someone's interpretation.
So I can't go up and down, I have to go left and right.
If that's how they work this. Now, and technically this device is 3-axis, but it depends on how that person wrote the code, and I just don't know. We could probably go look and see the code they wrote. So that is one of the things, I talked a little bit earlier how I think this is a great thing to start with, but you can kind of run into some limitations because the people at Adafruit have done such amazing work to make things easy for you, but sometimes they make it a little too easy. And then, if you were like, well, I really want it to respond in this way. So it is still possible to do that, but you might have to drop into JavaScript or even go get the Arduino IDE. So you have some options to go deeper. Now, so everybody, it seems like most people got through that little thing. So what I would say, a good first thing to play with, and this is something I would always encourage you to do, is once you've kind of got the tutorial, is look at it and be like, okay, but I want to do something a little different. Like I want to change it and try something a little differently. So just as an example on what I might do to think about that, I might look at this and be like, well, actually, I kind of agree with Brooklyn. I don't really like the way the shake works. Like it's a little unreliable. I would rather just be able to push a button, right? And so once I'm done with the tutorial part of this, oh, you could, yeah, I'm sure you could. In fact, I mean, right now it's a little. That's funny. We could look and see because it actually does have some tilts and face up and face down, free fall, for example. So these are G's. This is how much acceleration you would have to hit before you hit it. So you could try those. But I think I want to keep it really simple, and I just want to say input when button A is clicked. Right? I don't like the shake. It doesn't work well for me. I'm finding it not very useful. So I'm going to drag this whole thing in exactly. And now the event that I'm looking for is button A. And so if I click button A over here, is that actually A?
It needs to load. Once it has the copyright.
Oh, right. I think you're right. The play button. There we go. Wait,
Because you still have the on shape.
Let's ditch that on shape. I
Makes it
agree. Let's delete it. Okay.
It just makes it weird.
Yeah. It may be unhappy with multiple bins. Okay, but it seems like we're okay now. So it looks like it is loading, and I can click this. And now it's happening when I click a button, right? But
if I turn this
one of the things that I talked about this that I think is especially cool is that it does have capacitive touch also, right? So it's not just buttons. Some of these pins are touch sensitive. So something we could do here is say, for example, on touch A1. So if I say on touch A1, now if I touch the A1 pad, and it looks like we just have to wait while it's thinking, it will do the thing. It will do the logic, right? And so I'm now going to download this one, and I'm going to call this Siren Touch.
So if you just touch that little piece, it will do it.
It should, and then hopefully the thing that I think would be extra cool, so I'm going to hit the program, and then I will hopefully end up in my little fun Blinky program made. I should just hide this. Blinky program mode, and then I have my C Play boot, and then I'm going to go look at my embarrassing high school pictures again. We're going to drag the touch in, and we're hopefully going to program. And then I'm going to look for the pin that's labeled A1. And there's lots of writing on this, so it can be a little hard to find, but I just found it up here in the corner. So if I touch A1, it should happen. Now, what is really cool about this, and I think that maybe unfortunately I did not grab any alligator clips. Let's see if I did. Okay, we'll just look at that in the other room. But the thing that is cool about that is I don't have to touch that directly. I could hook a wire to that. I could hook copper tape to that. I could hook one of those alligator clips to that and make it where I touch something else to trigger that. And that's something we'll look at when we go do some more hands-on stuff in the lab. I think we're almost ready to go in there. Is this making sense to everybody?
Yeah.
Like the general concept here? And so I think the thing to see is that it's really easy to just play with this, right? It's really easy to just dive in and start doing things. So for example, if I was like, I kind of want to make a little piano. I just want to say, you know, we have these touch pins. I want to start to make a little piano. So I might do something like, okay, I'm going to say input, and I'm going to say, yeah, let's say touch A1, for example. And I'm going to say when I click that, I will say, let's play some music. And I'm going to look for something in here like play a tone. So that sounds pretty good for me. So we'll just play a middle C for half a beat. And I can experiment with that up here and just see if I like it. I can find A1 again. So I can play it. I can get that little note. So I'm like, okay, that's not bad, but it's really short. So let's try to play it. Let's do a whole note. We'll wait for that to load. Okay, so now I can touch it and play middle C, but obviously, if we want to play chords, we should have a few more notes. So I'm just going to Control-C, Control-V this and see if that works. No? Okay, I think I have to Control-click or right-click, depending on what mouse you've got. And hopefully, I can just say duplicate. Okay, no, I was able to Control-C, Control-V. So I just want to make copies of this. There we see duplicate when I right-click. Because I want to do kind of the same thing when I touch some other touch buttons. So let's do A2 and let's do A3. But now, instead of a middle C, so I'm playing middle C here, let's make this one middle E. And let's make this one middle G. And that'll be a little C major chord. So you can hear bum, 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 little C major. And so I've said that A1 is middle C, A2 is middle E, A3 is middle G. So that sounds fun, right? So let's actually see if it works. So let's go here and try to run our little friend. And we'll say A1. That's good. A2. Great. A3. Okay, so that is like starting to be like a little piano, and you can imagine I could hook it, but it's a little boring. It'd be more fun if it lit up. So I could also, if I wanted to, say that anytime I play, for example, middle C, maybe I also, oops, I actually wanted this. I don't think the order really matters. Maybe I want to say that middle C is going to be red, and maybe I want to say that middle E is going to be blue, for example. And I want to say that middle G is going to be green. So I'll just have sort of an RGB thing with the middle C. And so I'm just making my simple little instrument and, you know, just kind of looking through what things I can do, what's possible. We can see all this kind of logic, if else, all these other things. But, we won't even go into that for now. We'll just kind of stick with some of the simple pieces, some of the simple building blocks. And this seems reasonable to me. So I've like made my little piano and I'm going to test it here. So I played and it turned green. So that was good. And that was good. And that was good. But you can see something funny is happening. The color isn't changing until the beat ends. And so, yeah. So not only is it after, it is actually blocking. And that's a programming concept that we won't necessarily fully go into, but it means, or it appears to mean to me, that we don't go past this until the tone is done playing. But you could imagine a version where it's like, oh, I could just play it and keep going. In this case, it's going to wait. So I think I would actually prefer to do it in the other order. So I'm going to just swap this around just as an easy, maybe easy fix to just say, actually, I want to change the color immediately. I don't want to wait too. And so just totally be willing to do that. It's very unlikely that you will hurt anything or break anything. Just play with it. If it doesn't work, it doesn't work, and you can just try again. And again, our little simulator will hopefully help us. And now you can see the change is immediate. So that seems better. And probably there's a way to like play music without delay. I just don't know what it is. Like maybe that's what ringtone is. I just don't know. Or maybe actually, I bet that one just plays continually until we're ready to turn it off. So
On that play melody, if you click that play melody one, you can also write.
oh yeah, write a little song, right? So it has a little sequencer, so we can like make a little sequence and have a little song that plays. So for sure. And so now I'm just going to take my little touch piano, and we'll download the little touch piano. I don't know why there's two download buttons, but did we play a sound forever?
Forever.
Nice. So that forever loop will just do something over and over again. And it's actually fine to do that, Roberta, but the thing you would probably want to add is there's something called a delay that would just, right now it's just doing it as fast as it can. But if you look, and some things, if you're having trouble finding something, there's a little search button here. So I'll type delay.
Or it's delay or pause.
Oh, is it called pause? Is that the right term? Okay, normally in Tougher I would call it a delay, but you're right. They call it pause. Okay, so we're looking for pause. And so I could say, for example, but between each time I do it, maybe I want to pause for 1 second.
You can take that, drag it out.
You can get rid of that if it's not working out. But if you wanted to, we could play a sound and just say, oh, I want to play every 1 second. So for example, it'd be nice maybe, oh, if there was like a little wood block or something that was a little like it seemed like there is. Not super pleased with the sound selection, but that's okay. Wow, there's not even like just a metronome tick. Okay, well that's something we may have to solve. But I could play this, and in this case, it would just happen once every second instead of happening repeatedly over and over and over again. So let's try this. So did we not go? Oh, I'm sorry. I said stop sound. That's the total not thing we wanted to do at all. That would have been, let's try that again. I want to play sound, and then Brooklyn is exactly right. It's a pause, not a delay. And then we pause for 1 second. If we want, and if we wanted to have something just kind of like do a bading, wait a second. So this, it will play a bading every second, and that can be my little metronome that I could use as I play. Yeah, it's a Mario coin sound for their bading. So if I wanted that to play as a loop, not the best loop, so maybe I'll stop that. But it is, you can definitely do that if you just want something to happen over and over again.
What are the sounds there is?
It's a pretty limited little library, it looks like. And I'm not sure actually if this interface gives you the ability to do that. So something that's kind of funny about this is this has a very little, there's really not much memory on this device. I think that's what this little chip is. Where is it?
So like if you have old programs in that, it only puts you
New project.
Well, so it's basically one program at a time, but even the sound that you're playing, that bading, is actually part of the code. And so I'm not even sure if we can see the raw code for this, but it actually would be encoded into it. So instead of being like a sound file on MP3 that's high quality, the sound is part of the code that goes in, which is kind of a funny thing, which is another place where something like a Teensy is a bit nicer because it has a fancy audio breakout where you can do fancy audio stuff. So it seems like everybody's getting the basics of it and is starting to get some ideas. I think it's really worthwhile to like click these tutorials and just look at some of the some of the possibilities and look at some of the things you can do and look at some of the things other people have made. For example, this night light looks fun, so you can check out the night light. It probably uses the ambient light sensor to say like, oh, hey, when light goes below a certain level, turn on some, let's see, we can skip to the end. Let's see, maybe it'll let us not click.
I'm just gonna make a little song that it plays.
Yeah, do that. I think it's great. I really like
It's not
that.
my song, it's gonna be a song from a game.
Oh, of course. That's fine. So here we see there's like a set pixels to blue in these little set brightnesses. So yeah, it looks like there's some logic here that will say, actually, where is it reading from the, maybe I misunderstood the instructions here because I thought we were going to set it based on the dimmer. Is that not true? Maybe I grossly misunderstood the assignment with the night light. Let's see. Glowing light that continuously dims then brightens. Oh, okay. Well, never mind. I thought it was going to be a brightness controlled light, but that seems to not be true. I think this is a really cool one to play with, especially as other people make noisy things. This little, just to be clear, we can make our own night light. That one didn't do what I thought it would, but I think this one is really cool because it will make a little loudness meter using its cute little digital microphone. And so it will create something. So if we wanted to say graph sound level up to 255, 255 is, there's a reason, we're going to graph sound level, and we'll change this to 255. And so if I run this now, the audio input level, which will be this little slider in the corner, will kind of show a little volume meter that goes up, right? And so now if I download this, and I put this on the device, and I'll go in its little programming mode. I hear some beautiful music happening. So we'll do the little loudness necklace and grab this here, and we'll see our little C play boot. Is everybody doing okay as far as programming and getting code on it?
I'm curious if you have to unplug it and replug it each time if you're updating.
It should it's supposed to just be press the reset button in the middle.
Oh, okay.
Sometimes though, I find that I have to double click. So I think in the dead center, there's a little reset button, and that should hopefully turn it bright green. Yep. So now when you're in that mode, you should be able to go to the Finder.
And then it'll show up.
Yeah, it should. If it doesn't, definitely let me know. But I think that's the idea. Okay. Yeah, it's a cool setup, but it can be a little finicky. Okay, so now you can see I have this little loudness meter. And as I speak more loudly, or if I mean to it, hello, you can see it kind of responding to the volume of my voice. And so as I mentioned, there's some people that have done some kind of cool voice reactive things for their masks and stuff like that. So it's almost noon. I talked for way too long, but hopefully everybody's playing. So I think we should stop soon, unless there's any other comments or questions that should be immortalized forever. Otherwise, we'll just keep playing. Okay, awesome. Everybody is at home. Thanks for tuning in. We will have, there's much more to come on this, but I think, again, you should be able to jump right in. Even if you don't have this device, just go play with it. And then if it seems like something you're into, you can just order one from Adafruit. They're not super expensive. So I think that will be the end of the day. Thanks for joining us, and that's it.